Hi guys, welcome back to Ades Workshop. I know it's been a few days after episode 5, but this is going to be episode 6, as you're watching it, of the ball turning tool. Let's have a look at what we're going to do, or what material I've got for the tool holder that's going to hold the little carbide tip. So I've been rooting through my old toolboxes, and I pulled out a piece of, what it is, a piece of gauge plate, or it's an O1 steel, the same as drill rod or silver steel, that sort of thing. It's an offcut. It was, but I've got a foot long piece of it, but I've hacksawed off 60mm. Good news is it's ground on this face. It might not look it, but yeah, it is ground on that face, this space, and on this space. But it's 1/2 inch thick, and my slot is, nominal 12mm. So I will have to machine off the one face of it. And again, I'll have to machine that face because it was a saw cut, and these two faces, which are a saw cut. So I think we'll use a 4-jaw for that. I've been asked by a viewer who has the same lathe as me about my winding handle. Well, I didn't actually make this winding handle. It was a gift from one of my viewers. But yeah, basically what we've got is a steel tube which just fits up the tunnel of the lathe, and it's got 2 cuts up it. And if I just take it apart, can I get the nut off the end? Yes, I can. Okay, so we've got a piece of stud rod up the middle, a taper machine in the end of the tube. The stud rod has a taper welded onto it, and as you can imagine, if you were to push the taper into the taper, it's going to expand the rod. So yeah, washer on the back. Just get that nut back on. Here we go. So yeah, I simply put it into the tunnel of the lathe. 17mm spanner, where are you? Here we are. I can just give it a nip up with a 17mm spanner, and that is the winding handle I use for tapping. Yeah, as you can see, my vise is very close. I didn't think too deeply when I put the vise where it is, but yeah, I mean, I use it all the time. It works great. Yeah, so just simply give it a tap, and out it comes again. It's a simple thing. It's a welded construction. The handle turns on the end there with a nylock nut. It's a handle welded on. It's welded onto a boss. It does everything I want it to do. But one thing, when you're using a winding handle, as you can imagine, if you were to turn the lathe on, you're going to have this thing flying around, and it's really dangerous. So if you're going to make yourself a winding handle, hit the emergency stop on the lathe. It's not something I use often as e-stop, even switch it off at the mains, but hit the emergency stop is what I do. So basically, if I pick my winding handle up, first thing I do is hit the emergency stop, and then and I have a few times inadvertently, been in the middle of something, gone to start the lathe and thought, oh, why isn't it starting? Oh yeah, the emergency stop, take out the winding handle. It's a reminder for myself. So yeah, just thought I'd share that with you. It's a simple thing to make. But it's very useful, for basically for threading. So yeah, I've got it set up in the 4-jaw, and I don't think it's going to take very much to clean it up actually, which is good because I haven't got any spare material to play with really. So yeah, I'm just going to face off this side. I'll have 2 flat and square sides, or 4 then actually. I've put the ground side against the chuck, tapped back hard. And I should get a face on the top here that's pretty good. It's all going to be machined away afterwards, this face, or a lot of it. So yeah, I'm not too worried about it being perfect. I just want it square and flat as a sort of starting point. And again, with the ends, I'm going to do much the same with them. Just, basically turn them square and flat so that yeah, I mean, it's basically blocked up. Let's see if that's cleaned up. a little bit on that corner, but if I make that corner part of the bit that's going to be cut away, I'm not worried about it. So we'll call that face done. So we set it back up in the forge jaw, and I'm just skimming one of the ends. It hasn't cleaned up that. I don't think that end, well, there was a saw cut on one end. Yeah, it needs more. I've got a couple of mil to play with on the overall length. Where I sawed it off, I sawed it off at 62, and it's going to finish size at 60. Let's just have a look. Yeah, keep going. You just lock my carriage on that. It might be pushing away. Yeah, I mean, this part of it is the basically the milling equivalent of blocking up. It's surprising how flat and square everything becomes when it's held, because it's all held square in relation to the jaws of the chuck, and that is going to need a tiny scratch more. I just put a touch on with a compound. It's not going any stupid speed because it's an intermittent cut. So I'm doing what, 500 and something RPM. There you are. That's that end cleaned up. So I'll flick it round the other way and machine the other end to my length of 60. So I've just set an adjustable parallel in the slot to gauge your width, and it's coming up actually it's coming up I don't believe it, but it's coming up on the mic. I don't know whether you can pick that up, at 12mm on the button. I've got a normal lathe tool here that mics up at a couple of hundredths under. And that fits in there beautifully. So yeah, I think a couple of hundredths under 12mm is where I'm going to aim for on the thickness of this part, so that it drops in the slot in the same way as that lathe tool does. So I've got a slight change of plan. I'm going to leave it a couple of hundredths over 12mm, and then with the use of a large amount of elbow grease, draw filing, and probably 400 grit, I'm going to fit it manually to get it to run just nice in that slot, and that will allow me to do a little bit of dressing in that slot should I need it as well. So that's theoretically a finishing cut on there, and I'm not sure how parallel this is going to be. So I've measured it end for end, and it's within a couple of hundredths. So yeah, if I leave the small end at 12mm and the large end at like 12.02, which is hopefully somewhere near where it is now, and of course it will allow me to remove these machining marks as well, but it'll come out in the polish. Well, I've got to a point now with filing it and what have you that it fits, but yeah, it fits, but it's too tight. Bit more. See in the centre there's just a small machining mark left. So I've decided to put a little angled cutout on the one side of my sliding block. It's not to scale, but at a point 2mm from the very bottom up to about 8mm, so it's all withheld within the slot, so that when the little brass slugs are screwed and push in against that face, it's always going to try and force the part or the sliding tool holder down into its location. It's a sort of it's a dovetail effect, but obviously the ideal scenario would be you know, a dovetail on this side of the block, but I didn't want to go to that extreme. But this will actually, you know, help in keeping it down hard against the bottom face when it's in its little slot, you know, which, you know, the slot here. So yeah, just a little sort of afterthought I had, but yeah, it's certainly going to help. So I got it all. So I've got it all set up now. I've clocked it all into square. And I got a little 3/8 milling cutter in here, and I've set it on a height so that it started cutting 8mm down from the, it's upside down from the bottom face, and I'll just keep machining until that taper blends out onto the little line I've scribed there, which is around the 2mm mark. So yeah, going to keep out this shot here, taking 0.1 at a time. You get the general idea. I'll bring you back when I'm done. Well, there it is. I've finished machining the little angle. Didn't take very long at all, actually. I think it was about 5 passes, a nice slow one at the end. So yeah, I mean, the angle starts 2mm down from the top, down to about 8mm, and that should miss the grub screw should pick up somewhere in the middle of that angle and help pull it down into the bottom of its nest. So just using a little slipstone. Just take the sharp edges off the top and just give myself a nice flat surface in there. There's a few little machining marks, but a minute or two with the oil stone just to dress them off. And I've deburred the ends with a little tiny file. So let me try and let you into the mysterious way that my mind works. The diameter of the body is 60mm. So to cut no radius at all, that tip, if this block were flush with the outside, would want to sit 30mm from this end. Well, yeah, I mean, I don't want it flush with the end of the tip because it might get rubbing issues, but if I said 30.5, just so the tip overhangs the metal a little, so if I cut away 30.5 back down to this depth, down to the base plate, rough it out, that will give me the, you know, the main body of the material removed. We will be putting angles on the sides afterwards, but we'll come to that at a later date. Now my thinking is that when this block is flush, I'll set this tip up, or try my very hardest to set this tip up so that the center of the, or the tip of the point of the tip is on the center of rotation when this block is flush. So if I were to move this block back, say 6mm, and I could measure the step from the end, 6mm, I'd know that would give me a 6mm radius. So say for example I was turning a piece of 30mm bar, but I didn't want to put a full ball on the end. I just wanted a 6mm radius on the corners. I would have the facility, without, you know, doing daft measurements, a baseline that 6mm step back this way with this block would give me a 6mm rad and a 7mm and so on and so forth. On the same note, because this is 60mm long, if I wanted to machine a concave radius, say in a diameter, say I wanted to machine a 3mm radius, something like that in a diameter, I could do the same thing by moving the block the other way and measuring from the other end, or I could still measure this end. The step outwards would be 3mm. So yeah, that's rightly or wrongly, that's the way my mind is working at the moment. So I think my first procedure is going to be describe myself a line 30.5 back, a line down, and then a line 10mm, and I think I'll probably get the good old hacksaw out and rough out 90% of the material that way, and then we'll get it up and mill it to size. So I've treated my hacksaw to a brand new blade. I do like these blades, Sandflex bimetal blades. This one's 18 TPI. Yeah, it's a Barco made in Sweden. But yeah, I swear by these things, they are excellent. So you know, they're more expensive than the cheap ones you can buy and all the rest, but you know, they last and they go on and on and on. You know, as long as you're not daft with them. So yeah, I do like these blades. So I'm not going too mad. I'm about 2 millimeters off my line, I suppose. Keep it nice and square. Oh, it's a pleasure to use a new hacksaw blade. And I'll go down to my line on the side. So yeah, I got a good way to go yet. I don't know whether you guys noticed that I put a big black letter X on here. When you've got a line that's central about in something, it would be really easy to hacksaw the wrong side of the line. So I put an X on. I know that's the scrap bit. Keep that side of the line. Just because, well, it's an easy mistake to make. So we've sorted off. I've set it up in the mill now, back hard against a parallel. And I actually, let me just see if I can show. I slid this up to the top and touched off on the end. So that gives me a reference point with a 0 to come in and machine this back face at 30.5 mil. Now, I've just done a little scratch there, and I obviously dropped the block back down again, brought the cutter in, taken a little scratch off that face. You can see a little bit of machining I've done there. And that measures up at 12 mil, which is where I want to be. In fact, it's 11 at this end and 12 at that end. I erred on the side of caution when I was hacksawing it off. I thought, well, if you're going to wander away. So yeah, it did. Yeah, I've gained a mil at this end, but that's fine. So I'm going to machine back now and machine this face off to the finished size of 30.5. Now, when I can flick it round and do this face to its 10 mil, I'll leave 2 millimeters in the corner, so there'll be a little square in the corner, 2 mil by 2 mil, which I'll be able to dress into a nice little radius in the corner just to make it look nice. So I'm not machining this bottom, well, it is scratching across the bottom face, as you can see, so I'll just work my way in. I've already gone that far. I'll lock the carriage on the next pass, I think. That's 28.75 deep. Yeah, and I'll lock the carriage there on 29. Just gently work my way across. So I finished the bottom face off to the 30.5. And again, it's got 2 mil further to go in. So I'm going to leave the little 2x2 square in the corner for now. What I'm going to do, I've got this in here again against the stack of parallels behind. I'm going to take a cut across this face at the top here and take it to maybe 10.2 millimeters. And then I'll gradually bring it up, you know, take the next cuts, bring it out so that it's 0.2 oversize on this face, leaving a little square in the corner. So right down to within 2 millimeters of this face. And then we're going to get a single point cutting tool up with a 2 mil rad on it, but we'll come to that as the next step. So let's just call this a roughing out. So I've just measured the end of this up, not quite touching there. I'll give myself a 0. I measured the end of it up and it was 10.97, so I got a bit to come off, but I'll do a clean up pass and get the calipers in there, give it a measure, and when it's at 10.2 I'll set a 0 again and I'll do that all the way down the face. But that's not quite cleaned up. Okay, so that's roughed out. The thickness there is 10.25 millimeters all the way along there, and you can see the little 2 mil by 2 mil square in the corner, which is going to become a radius when it's removed with a single point cutting tool. So I'll get that all set up and then I'll talk you through it. Don't know how well you can see it, but I've got a little single point cutting tool there, and I've ground it up. It's got a 2mm radius on the end. I'll come out from that shot, and I've set it so that when it's on its lowest point of the swing, can't really show you at this angle, but I set it with a cigarette paper on that bottom face, and I basically kept tapping the arm down, 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 until as I rotated it by hand in this sort of style, it just caught the cigarette paper, and that gives me about 1/1000th of an inch off that bottom face. So then what I'm doing, and I've just done a couple of little test bits. Let's see, I don't know whether I can show you where I am so far. Well, yeah, I mean, I've taken 0.2 off the front face of that little 2mm square bit, and you can see the radius starting to develop. So I'll keep working my way in, and I'll show you when I'm about halfway there. Now, I can't go too fast with this, because the tool I've got in there is, it's not high-speed steel, but it's a hardened punch blank. It's a punch for punching sheet metal, or a standard sort of punch. It was an old broken one out of a press tool. I've got lots of them thrown in the box over the years. You know, ones that have been taken out of press tools, sort of broken ones, or ones that have become edged or been reground to the point where they were too short, you know, to be of any further use on a tool refurb or something like that. So yeah, not much to see, but all it's doing is cutting at the moment on that little 2mm square in the bottom. So I think on this cut, I can just hear it ticking. It's just started to touch on the back face, or on this face as we look at it, and the face against the vice. As the rad comes into play in the bottom corner, you hear a bit of a chattering, because it's cutting all the way around the radius. As long as I take it gently, it's fine. So I've got it set up in position where it's going to live when it's working, you know, near as what's it. I've got a 5mm diameter ground pin in the collet. Ignore that little step. I need to dress that down. There is a little step there. It's probably 0.1, but better to be a bit high than a bit low, eh? Right. So I've used my adjustable parallel, and I've got that fitting in there beautifully. So that gives me a height of that size plus 2.5 is the center height of the lathe, or where my tip needs to run, above that face. So let's take it to my sketch. So I've got the 12.66, which was the measurement of that, plus 2.5, 15.16. Oh, we're getting in the way there, sorry. 15.16 is the height above my the rotating the tool holder, or swivelly bit as we all like to call it, is 15.16. Okay. Now I've just measured up my two types of tip that I use, and they're, you know, within a couple of hundredths of each other, 2.45 millimeters thick. So if I take the 2.45 from 15.16, gives me 12.71. Now 12.71 would be the height above the base that I need to machine it so that when the tip is on top of it, it sits at the correct height. Well, at the moment, my block is 13.9 above the base, which means I need to machine it down 1.19 millimeters. There we are, we got there in the end. Slight problem with this is that the little backstop then that's going to hold the tip is only half the height of the tip. I knew I was getting close on material, that's why I was taking bare minimums earlier on. But yeah, I can live with that. So yeah, 1.19 mil I'll have a step, so it's near as damn it's half the tip thickness. Now the issue there is when it comes to the step. I got another little drawing here. All right, bring you out. A couple of little drawings on the bottom of my what's it. I'm actually forward planning for a change. I've measured the distance from the back face on the tips at the top edge, and they measure 9mm. If I sit them sort of half in the calipers, they measure 8.7. So at that height, halfway up, I'm losing 0.3 of a mil. But I'm only concerned with the front face and with the back face, so I can half that, which gives me my 0.15. I've written 0.15 closer. Okay, so we machined back, or the plan was always to have the tip sticking out half a mil, and we know it's 9. So I only need to machine it 8.5 back from the front edge to get the half mil stick out. But because I'm only halfway up the tip, remove the 0.15 is 8.35. I've decided to do it 8.3. And looking here, you can see if I do it 8.3, the worst thing, the worst thing that can happen is I've got to file a little bit off the far end of the block. So that's better to have to remove a bit than to put a bit more on. And I'm going to go for a depth of 1.1 as opposed to 1.19. Again, on the grounds that I can remove a bit more, but I can't put it back on again. So yeah, I'm erring on the side of caution. I'm going to do an 8.3 step. Let me bring you back to my block. Yeah, whoop. From the front face here, I'm going to machine back 8.3mm and with a depth of 1.1, well, on the plus side of 1.1, but 1.1 mil. And that will then, I mean, it's all screwed down and tightened down and pulled down into the block. That should give me, if anything, a little bit high. But as I say, I can file a bit down, I can dress a bit down, I can't put it back on again. So that'll be my next procedure, to set up and do that. But I think, well, there we are. I think that's about it for this episode. I didn't expect to be able to get one out so soon, but the weather's been really awful here today, which has meant I've been able to come in the workshop and haven't been able to do any work outside. At least I haven't got to water the flowers this evening anyway. So as usual, thanks for watching, guys. Thanks for subscribing, and we will see you all very soon. Cheers now.